Hello everyone, my name is Soong. I'm gonna be with the IT Monkeys, including Tobias, Isaac, and Jesus. We're still developing our Timekeeper application, and this is our presentation to present our traditional models. So we're gonna be using the following traditional models to define our group solution to our business problem from last week. We have our event table. It's going to be a chart used to list our important events our system must respond to. And then we have our ER diagrams, entity relationship diagram. It's going to be used as a visual blueprint of the data our system is going to be storing and how all of that's related to each other. And then we have our DFDs, or data flow diagrams. We are going to have our context level diagram, our level 0 diagram, and our level 1 diagram, showing you kind of like an umbrella of going deeper and deeper into each of the processes.
And this is just a brief overview of our business problem and our requirements. So the problem is that contractors and organizations have trouble accurately tracking employee hours and managing attendance in worksite locations. These challenges lead to inaccurate payroll processing and increased administrative overhead and add a lot of risks. So the first requirement was that it must be simple and easy to use for employees and employers, whether remote or in local work environments. Our second requirement was that it had GPS tracking to start and stop relevant timers in relation to the job site. And then our third requirement was that you could export the time into a timesheet to allow the employees to easily turn in their hours. And this is our event table, which shows the event, the trigger, the source, activity, response, and destination. So for the first one, the event would be the user presses a button to clock in. This would trigger the clock in function. The source would be the user, of course, and then the activity would be to start a timer for the shift. And then the destination would just be the program. For the second event, when the user presses the clock out button, it would trigger the clock out function. Of course, the source would again be the user. The activity would be ending the timer for the shift. And then the destination would be the work folder. And then the third event, when the user logs a break, pretty much the same thing, except for it logs break time instead of the ending time. And then the event, when the user presses the generate timesheet option, it requests some data, and then it generates a timesheet and exports that as a PDF. And then when the manager schedules tasks, it triggers a schedule tasks function. The source would be the manager this time. And then the destination would be the user account so that they can see the tasks they must do. And then the last event is when the user sets a location for clocking in. This would also trigger the clocking in function. And this time the source would be the GPS tracking, and then the destination would be the work folder again.
Okay, and then this is our ER diagram. It shows our entities, which are going to be the employer class and the employees class. And the arrows kind of show the relationship between them. The single line shows one, and then the many shows many lines. So you can see the employer has a one to many relationship with the employees, the worksite locations, and the payroll reports. And then for employees, they have a one to many relationship with the time entries, and then a many to many relationship with the worksite location, and then this is a mandatory relationship with the payroll reports. So this just gives us kind of a layout of all of our data, the following attributes associated with each of the entities, and we're going to be using this later on in the process to kind of guide us.
All right. Now we're starting with the context data flow diagram. And this diagram basically illustrates the overall flow of data within the timekeeper system. Highlights how the external entities, such as the employer, the employee, and the payroll system, interact with the system throughout processes such as clocking in, clocking out, task management, and report generation. And it's basically a high level view of how the data enters and exits the system. And for our level zero DFD diagram, it basically provides a general overview of the system's core functions, and it shows how the data flows between the employer, the employee, and the payroll system. This includes functions like clocking in, clocking out, logging breaks, resuming work, clocking out, as well as task management and local data storage and cloud sync. For the level 1 DFD, this goes into a little more detail about the clocking in, clocking out process. Basically breaks it down into sub processes such as validating the entries, logging the breaks, and it shows all the relationships within the system, like the employee, how it interacts, and how each function interacts with the system. And as you can see here, it also shows the generating report functions and how those get stored into the time entries and how the data flows basically.
All right, and then we go back to the DFD level 0, but this time together with the pseudocode. And yeah, we're going to start with the user workday flow. There's the start workday function, which begins the workday by clocking in and looping through the user actions until it's going to be clocked out. So then, of course, you have the clock in function, which records the start of the workday, the clock out function, which records the end time of the workday. Then you have a log break function, which marks the start of a break. And then you also have the resume work function, which will end that break and resume to the active work. And then you have a review productivity function, which will calculate the total work hours. And then you also have a generate summary function, which will create a summary of the workday's activities. And then you also have an export report function, which will export the summary for payroll or general records. And then we move to the task management module. Um, so we have the manage tasks function. So this basically directs user actions to the correct task functions. And then we have the add task function, edit task, delete task, add a subtask, um, categorize tasks, set recurring tasks, and so on. And so these are all functions that only the manager or employer side of that program can use. And yeah, then we go down to the data storage module. So we have the store data function, which will decide where to save the data automatically based on connectivity. So if you're online, or no, if you're offline, it will go to the store locally function, which will save information on the device. If you're online, it will go to the sync to cloud function, and this will upload it. Uh, this will upload the data into the cloud. And if you're offline and you come online later, the information from the device will be automatically synced with the cloud as well. And then we have the integrations module. So we have the integrations function, which runs external services automatically when a specific event occurs. Um, so we have the GPS verification function, which will run with the clock in and clock out functions if the GPS is enabled, of course. Then we have the send notification function, which starts, stops, updates the timers, and also alerts um, when break. so when you have a break. And you also have the calendar sync function, which will auto fetch shifts or events when you're online. And we also have the export to invoicing function, which will auto export after the generate summary function if the policy allows and if you're online. Otherwise, it will wait, and then once you're online, it will do it. And then we have, of course, the encrypt data function where all the data will go through. And yeah, so we are safer. And then we move on to the conclusion slide. And so for this sprint of the development stage, we reviewed our problem definition statement and used those traditional models here to show how we will solve the problem. And now that we are wrapping up our traditional models for the development of the timekeeper.
All right. Thank you so much.